Thanks to Brilliant for supporting this episode of SciShow. Go to brilliant.org/SciShow to grab a gift subscription to help your loved one spark a lifelong love of learning. When you learned about the Earth's interior in elementary school, you were probably shown a diagram that looked like a perfect layer cake. You had the thin crust, the thicker section of the mantle, the outer core, and the inner core, and everything was smooth and even, perfect nested spheres. I hate to burst your bubble, but we've known for a long time that that diagram just isn't true, at least when it comes to the mantle. In reality, the Earth's mantle is far from a perfect smooth layer. Instead, it has some gigantic blobs the size of continents in it. And we're now learning that those irregularities may actually be fundamentally important to what's happening up here on the surface, more than 2,000 kilometers away. To do this kind of work, scientists use seismometers, instruments about the size of a gallon of paint that measure motion in the ground. They're most famous for studying earthquakes, but they can also be used to examine other vibrations in the Earth. And if you know what you're looking for, seismometer data can also help you figure out what the planet's interior is like. For instance, when a big earthquake happens, it releases energy that radiates out from the epicenter in waves. These waves travel through the Earth in all directions, but they don't go in a straight line and they don't all travel the same speed. Instead, their speed depends on the temperature and density of the rock they're moving through. For example, hot molten rock slows down the seismic waves a lot, while cold, dense material transmits them faster. So by using seismometers to monitor the arrival times of these waves at different locations, scientists can figure out the density of rock layers inside the Earth and what they're made of. This kind of work is called seismic tomography, and it's the main way we know what the inside of our planet looks like. It's also how we discovered that the mantle isn't a perfect sphere. The mantle is a thick layer of solid-ish rock, and it's super weirdly shaped. It's blobby and uneven, and there are two areas in particular that are very different than the rest of it. One blob below the Pacific Ocean and one beneath Africa and the Atlantic Ocean. These two arm-like protrusions were discovered in the late 1970s, and they're the size of entire continents. They sit right above the core mantle boundary and extend up towards the surface for hundreds of kilometers. Scientists can see them in tomographic images because they're low-velocity zones, meaning when seismic waves hit them, the waves slow down a lot. Then when the waves exit the blobs, they change speed again. This weird behavior likely has to do with what the blobs are made of. Scientists haven't figured out their composition for sure, but an experiment from 2017 suggested that the blobs might be iron peroxide. And they might have formed when iron-rich rock from the mantle reacted with seawater under enormous pressure and high temperatures. Seawater sometimes gets into the mantle as tectonic plates move underneath each other. And according to preliminary studies, a composition like this would give us the kind of seismic wave data we measure from earthquakes. Of course, scientists want to know more than just what these things are made of. They also want to know how they fit into the larger scheme of things on Earth. There are a bunch of questions to answer here, but at least right now, these blobs seem to be related to volcanic centers. Like nearly all the hotspots on Earth, that is, the volcanic centers not associated with tectonic plate boundaries, seem to be located above these blobs. Hawaii is pretty much centered over the one below the Pacific Ocean, so it might be the cause of the plume of molten rock that feeds the Hawaiian volcanoes. The other big blob may be related to older extinct volcanic fields, like some in Africa that erupted huge volumes of lava called flood basalts. And in addition to these two main blobs, there are also some smaller ones, including one that might be contributing to the volcanic system of Iceland. Like, we're still not sure if they're left over from Earth's formation, or if they started out at the surface and sank down through the mantle at some point. And if they did sink down there, well, is there any possibility they might become buoyant enough to rise, like wax in a lava lamp? The answer depends on their chemical compositions. If that composition could cause them to slowly rise and sink over millions of years, then those movements would affect how heat is circulated in the Earth. And maybe, just maybe, that could explain why the Earth's magnetic field sometimes reverses. But you shouldn't worry. A magnetic reversal caused by a rising mantle blob would take millions of years to happen, so you don't need to go buying a new compass just yet. As seismic tomography improves and more scientists get in on the work, our understanding of the Earth's interior will get better and better. And with every new image, we'll learn more about these mantle blobs, how they came to be, and how they affect the surface of the Earth thousands of kilometers away. If you want to learn more about seismology and how scientists study the inside of our planet, you can check out the Waves and Light course from Brilliant. It teaches you about all kinds of waves, including sound and light, but it also talks about seismic waves. In one quiz, you even learn how to figure out where an earthquake started just by knowing what the vibrations look like at the surface. And like all of Brilliant's other courses, Waves and Light comes with a bunch of great diagrams and explanations, so even if you're not a geology expert, you won't feel lost. Besides this one, Brilliant has other courses about science, engineering, computer science, and math. So no matter what you want to learn about, you've got options. You can learn more at brilliant.org/SciShow, and as a thank you to our audience, Brilliant is giving the first 200 people to sign up at that link 20% off their annual premium subscription. If you check them out, let us know what you think. And as always, thank you for watching this episode of SciShow.